All right, so trigonometry, the sine law. Now, when you studied kind of sine, cosine, and tangent in grade 10, so this is the continuation, you pretty much always try to do it for right angle triangles. But now, what about if you don't have a right angle triangle and you just have an acute triangle? So let's assume now acute triangle. So that means all our angles are kind of less than 90. Now, of course, the summation of them is going to be equal to 180, which is the case for all triangles. Now, let's take a look and see how we can tie in and create the sine law. So now, what the sine law says, okay, so we know that sine is basically the opposite over hypotenuse of a right angle triangle. You know, cosine was basically the adjacent over hypotenuse, and tangent is the opposite over the adjacent side. So those are the ratios. Now, it turns out that our sine law states that we can have the sine, and now I'm going to give you a little bit of a depth here. So I'm going to say we have this triangle A, B, and C. I'm going to designate, okay, so the angles, okay, of this A. So for example, so this angle right here, okay, I'll just simply call it A. I mean, I know that it's the vertex, so technically, you know, I should write kind of this, but I'm just going to write A for that angle. And now the opposite side to that angle, I'm going to call this, you know, little a here. All right, because it is right across from the vertex A. Now for the B, okay, so I'm going to call this angle basically B. So that's going to be this angle right there. And then the opposite side, okay, I'm going to call B. Now when I say opposite side, I mean actually the length of it. And then for C, so then this is going to be a small little c right here. And then this is the angle C. And what the sine law states is that the sine, okay, of the angle A, so I'll just write it like this, divided by A, so notice that it is basically a ratio between them, is actually equal to the sine of the angle B divided by the side of B. And also it states that the sine of the angle C divided by C, okay, is equal to all the other kind of proportional ratios that we have in here. So this is really what is we know as the sine law. Now, most students will just simply memorize this, and sometimes teachers won't really even show you where this comes from. But I will. Okay, so I'm going to try to show you where this comes from. Now, if you just want to use this, you know, you can kind of go towards the end. I'll do one example of how you can apply it to solve for things that you may not know in a triangle. But if you're interested, and I do encourage you to try to see, okay, if you can understand the explanation of where it comes from. And it doesn't actually come from something very complicated, okay? So let's try to break it down. So I'm going to remove this thing just so that it's not in my way here. I'm going to delete it. All right, I'm going to kind of clean this up, so let these angles come out. Okay, just clean it up a touch. And what I'm going to do first is I'm going to break down this triangle, and basically from the vertex, okay, C, right there, I'm going to drop a line which is going to be a perpendicular line. So that means, so this is 90, okay, degrees right here. And I've created two triangles. Now, when we have two triangles, then we know that, okay, and especially if those triangles are right angles, then all of a sudden we can start and go back and use our proportions, okay, or our ratios of what sine, cosines, and tangent are. Now, since I'm only concentrating on sine here, and that's what I'm going to do. So I'm going to call this line, so let's call this H, okay, which is kind of the height of this triangle, H1. All right, so that's what I'm going to call this height. And now let's think back of what we know about these triangles, okay? So for instance, so what I do know is right here. So this angle, okay, so what I have from this angle, so I know that the sine of that particular angle is equal to the opposite, now in this case opposite is that height, so H1, divided by the hypotenuse, And the hypotenuse, notice, is just B of that triangle right here. So I know that this is true. Now I'm going to do exactly the same thing for this triangle right here. And I'm going to take this angle, which is, now I'm going to take the sine of that angle, so sine of B. And that is equal to also opposite, which is H1, divided by the hypotenuse, which in this case is A. Now, just by a little bit of manipulation, so notice this B, okay, and then this A, I'm going to shift over to the opposite side. And what I'm going to get is, I'm going to get B multiplied by sine of A is equal to that height. But I also know that from right here, that I have A multiplied by the sine of B is equal to H1. Both of these are equal. So if I set them to each other, so if I set these to each other, so these two things are equal, which means that basically what I have B sine of the angle A is equal to A multiplied by sine of the angle B. And we're pretty much there. So now what I'm going to do is, to get my sine law, is I'm going to shift this A, okay, to the denominator on the opposite side, and this B, okay, on the denominator. So I'm going to divide both sides by A, and then shift that B, okay, and then divide it by B, so it's going to get shifted over on this side. So I'm going to get sine of the angle A divided by A is equal to sine of the angle B divided by B. And there you have it. So that's the first portion of basically the sine law. So these two things are equivalent. Now, to get the idea and get sine so that this also is equal to sine of the angle C divided by C, I can do exactly the same thing. So what I'm going to do is I'm going to kind of copy this down for us. And I'm going to just show you that you can do exactly the same thing. I'm going to just kind of take this. So let's copy it. All right. I'm going to bring it down in here. So paste it. Okay, like so. And now, just for convenience, just so that you can see. Okay, so I'm going to take this. I'm going to rotate it around. All right, so let's rotate it around all the way. Okay, so I'm just going to have it like that. Okay, so here, now I know that this isn't very nice. So here, I'm going to get rid of this right there. Okay, now to clean this up, so this is going to be my A. So that's my A. All right, so this is my A right here. This is my B right there. This is my B, and then finally, this is my C. All right, so I have that. It's still the same triangle. Now, what I just want to show you here is that let's do, okay, so our line, okay, so basically our height of this is going to be something like that. So it's going to go from here to here. And now this is 90 degrees. All right, so I just dropped a straight line, so a perpendicular line to that A, okay, to the BC that I have in there. And now I can do exactly the same thing as I just did above. So what I can do now is, I know this, I'm going to take this angle. So I have sine of the angle B is equal to, so notice that now here I'm going to call this H2. So that's the second height, all right, because it's different than the first height. So that is equal to the opposite of H2 divided by C. And I also know that I have sine of the angle C. So this right here is equal to H2 over B. And now doing the same trick, all right, where I know that H2 is equal to, so C multiplied by sine of B, which is also equal to, so notice from here, it is equal to B multiplied by the sine of the angle C. All right, so that's what I have there. doing exactly the same thing. I'm going to just kind of remove this. And now, so notice that you're going to get, by rearranging this, you're going to get that we have sine of the angle B divided by B is equal to sine of the angle C divided by C. And therefore, so since this is equal to that, we have our sine law. So that's where it comes from, and you can actually derive it on your own. Now, it is useful because sometimes, you might forget it, and you can kind of derive it to see. All right? So that is the sine law right there. And that's for acute triangles, not necessarily just right-angled triangles that we have. All right, so here's the example. Let's find all the angles and all the sides. Now, let's keep in mind that we're kind of restricting ourselves, at least for the moment, to acute triangles that we have. In this triangle, so we have the A, B, and C, and I'm going to just kind of label everything for us here. So let's do that. So this angle A, okay, so let's call this side A, and this is going to be the angle B. So this is our B right here. This angle is given to us, so that's angle C, and that is the side C right there. Let's try to see and find all the different angles and then all the different sides. Now, this is not a right angle triangle, so we're going to try to use the sine law in here. And so from here, so remember, so our sine law says that we have, so sine of, for instance, the angle A divided by, okay, A itself, which is the side, is equal to sine of the angle B divided by B, and then cosine, and then the sine of C divided by C. So that's the sine law. Now, we actually have, so we have B given, we have angle C given, and then we have C given. So I'm going to use this right here. All right, so we have that to try to solve for my angle B first. Now, once I have my angle B, I can find out the angle A because the angles just sum up to 180. So we can do that. And then from there, I can certainly find out what A is in terms of its length. Okay, so let's break it down. So I'm going to substitute everything back in here. That's going to be sine of the angle B divided by, now B itself is 12, is equal to, so now sine of C, so this is going to be sine of 55 degrees divided by, and that is 10. All right, so let's go ahead and solve for this. So this is going to be, so sine of the angle is equal to 2, so 12 multiplied by sine of 55 divided by 10. I'm just moving that 12 over on the other side. Now I can use the inverse to find out B. So sine inverse, all right, of all of this right here. We have that. Okay, so let's see what that gives us as an angle. I'm going to swing this over on the other side. I'll put it all into the calculator. 12 multiplied by sine 55 degrees. Again, make sure you have everything in degrees on your calculator. And it's calculating in degrees divided by 10. All right, so that is 79. Okay, 0.4. Let's keep one more maybe. Okay, so we have that. So that's my angle. So that means my angle, which is the angle, that's angle B. So angle A, so now I can find this angle because I have the other angles. So that's going to be 180 minus 79.41 minus 55. All right. So 180 minus 79.41 and minus 55. So this is approximately 45. Okay, so 0.59. So now I have all my angles. So notice they're all acute angles, meaning less than 90, so that's great. And so what else? We need this A. So if I want to know this A, so what I'm going to do is, now I'm going to take this. Okay, so let's copy. I'm going to bring this down. So I'm going to use this part of the sine law and substitute that in there. So I have sine of 45.459 divided by, so A I don't know, sine, now B was 79.41 divided by, I forget what B was there, B was 12, so that's that. And now we can solve for this A. All right, so if I rearrange this, I'm going to get A is equal to, so I can do that, and that's going to be, so 12 multiplied by sine of 45.59 divided by, it's going to be sine of 79.41. So let's do that now. 12 times sine 45.59 divided by sine 79.41 equals. All right, so A was approximately that much. Now I don't know what unit that was, centimeters, meters, or whatever it was, but that would actually be utilizing the sine law to find what we need, which is a great tool if you wanted. So always use this sine law if you're not dealing with directly with right angle triangles and you just have acute triangles. It will be super helpful. All right, so that is it. Thanks for watching.